Space is full of secrets, things so wild, so mind-bending, that your science class didn't even scratch the surface. What if I told you there's a planet where it rains diamonds, or that the footprints left by astronauts on the moon will outlast every human structure on Earth? And that's just the beginning. Today we're diving into 30 space facts so bizarre, so unbelievable, they'll make you question everything you thought you knew about the cosmos. Buckle up, this ride through the universe is about to get seriously strange. Here's something that might surprise you. The moon isn't standing still. In fact, it's moving away from us at roughly 1.5 inches every single year. That might not sound like much, but over time it adds up. The reason: tidal forces. Earth's gravity pulls on the moon, but the moon's gravity also tugs back, creating friction that slows Earth's rotation while gently pushing the moon into a wider orbit. So what happens in the distant future? Well, Earth's days will get longer, but don't worry, we're talking billions of years. And as the moon drifts farther out, ocean tides will weaken, changing coastlines forever. It's a slow dance between our planet and its closest celestial companion, one that's reshaping our world in ways we can barely perceive. Now let's talk about Venus, our neighboring planet with a truly bizarre quirk. Unlike most planets in the solar system, Venus spins in the opposite direction. Imagine a clock running backward. That's essentially what Venus is doing, rotating on its axis from east to west instead of west to east. Scientists call this retrograde rotation, and it's one of the biggest mysteries in planetary science. So how did this happen? One leading theory suggests a massive collision billions of years ago could have flipped Venus's rotation, like a cosmic wrecking ball shoving it into reverse. Or gravitational tugs from the Sun and other planets may have slowly forced it to spin the wrong way over eons. But here's another twist: Venus takes 243 Earth days to complete just one rotation. That means a single day there lasts longer than its entire year, which zips by in just 225 Earth days. Picture this: the sun rises in the west, sets in the east, and by the time you've had one full sunrise to sunset, the planet has already completed its journey around the sun. Talk about a topsy-turvy world. Imagine a world not of rock or gas, but of glittering diamond, a planet so dense and exotic, it makes Earth look ordinary. Meet 55 Cancri, a super-Earth orbiting a star 40 light-years away. This isn't some sci-fi fantasy, it's real, and it's one of the strangest places we've ever discovered. The reason: this planet is packed with carbon, the same element that forms diamonds. Under its scorching surface, scientists believe immense pressure has crushed that carbon into a vast, planet-sized diamond core. Picture a world where the ground beneath your feet, if you could stand there, would be worth quadrillions of dollars, but don't pack your mining gear just yet. 55 Cancri is a hellish place, tidally locked with one side permanently facing its star. Daytime temperatures soar over 4,000 degrees Fahrenheit, hot enough to vaporize metal. Meanwhile, the night side might be slightly less extreme, but still uninhabitable. And here's the wildest part: because of its carbon-rich makeup, the planet's entire geology defies Earth's norms. Instead of silica-based rocks like granite, you'd find compounds like silicon carbide, forming landscapes unlike anything in our solar system. Some researchers even speculate it might rain liquid diamonds in its atmosphere, with carbon crystallizing into gems as it falls. This cosmic jewel wasn't forged overnight. It's the product of a star system rich in carbon, where the building blocks of life as we know it took a radically different turn. While Earth ended up with oceans and organic molecules, 55 Cancri became a monument to extreme chemistry. It's a reminder that the universe is far stranger and more dazzling than we ever imagined. For over 300 years, Jupiter's Great Red Spot has swirled like a furious eye in the gas giant's atmosphere, a storm so colossal it could swallow Earth whole. But this legendary tempest isn't what it used to be. Recent observations reveal it's shrinking, and no one knows exactly why. Back in the late 1800s, the storm stretched over 25,000 miles wide enough to fit 3 Earths side by side. Today it's barely half that size. What keeps scientists scratching their heads is how this vortex has lasted centuries at all. On Earth, hurricanes dissipate in days once they hit land or cold water. Yet Jupiter has no solid surface to disrupt the storm, just endless layers of churning gas. The spot's energy comes from Jupiter's internal heat and its supersonic jet streams, which act like conveyor belts feeding the cyclone. But even with that endless fuel, the storm is slowly fading. Some researchers think smaller eddies breaking off at its edges are sapping its power, like cosmic friction wearing it down. Others speculate changes in Jupiter's wind patterns might be starving it. One thing's certain: the Great Red Spot is more than just a storm. It's a window into the chaotic heart of our solar system's largest planet. As it continues to evolve, astronomers are racing to understand its secrets before it vanishes entirely. Will it fade away in our lifetime, or could it suddenly surge back to its former glory? For now, it remains one of Jupiter's most mesmerizing mysteries, a raging giant on borrowed time. Far out in the solar system, Neptune holds a cosmic contradiction. This icy giant shouldn't be this hot. While it orbits 30 times farther from the Sun than Earth, bathing in near-permanent twilight, the planet somehow radiates 2.5 times more energy than it receives from our star. It's like a freezer burning with invisible fire, and scientists are still piecing together why. The leading theory: Neptune's core might be cooking itself. As the planet slowly contracts under its own gravity, the squeezing releases heat, a process called gravitational compression. But there's another tantalizing possibility: diamond rain. Deep in Neptune's atmosphere, where pressures crush methane into diamonds, these carbon gems could be sinking toward the core like glittering hailstones. As they fall, friction from their descent might generate extra warmth, acting like a planetary radiator. What's wild is how much this challenges our assumptions. Neptune's blue hue suggests cold serenity, yet beneath those swirling clouds it's a powerhouse of hidden energy. Unlike Jupiter or Saturn, which still glow from their formation billions of years ago, Neptune's heat output defies simple explanations. Some researchers even suspect exotic materials or leftover heat from ancient collisions could be fueling this icy paradox. For now, Neptune keeps its secrets locked beneath layers of superheated ice and howling winds. But every flicker of excess heat we detect reminds us the outer solar system is anything but quiet. It's a place where the rules of physics twist into something stranger, and where a planet so far from the Sun can still burn bright on its own terms. Picture a world so close to the Sun that daytime temperatures could melt lead, yet hidden in its darkest corners, ice lurks untouched for billions of years. Mercury, the solar system's smallest and swiftest planet, holds this impossible contradiction. While its sunlit side bakes at 800 degrees Fahrenheit, deep within polar craters, some untouched by sunlight for eons, water ice survives in permanent shadows. These frosty vaults are so cold that even a planet inches from the Sun's fury becomes a freezer. How did ice get there? The likely culprits are comets and asteroids, cosmic delivery trucks that smashed into Mercury over millennia, depositing water in its darkest recesses. But here's the twist: this ice isn't just a curiosity, it's a time capsule. By studying it, scientists can trace the history of water in our solar system, revealing how these building blocks of life hitched rides across space. Some of Mercury's ice might even predate Earth's oceans, preserved in a silent, airless deep freeze. Even more astonishing, radar scans reveal these icy deposits aren't rare. They're tucked beneath layers of dust, shielded from evaporation like treasures buried in a desert. It's a reminder that the cosmos thrives on contrasts, a planet where fire and ice exist side by side, rewriting what we thought possible in our own celestial backyard. Here's a cosmic riddle that baffles scientists to this day: how can the Sun's atmosphere be hotter than its surface? At first glance, it makes zero sense. The Sun's visible surface, the photosphere, sizzles at around 10,000 degrees Fahrenheit, hot enough to vaporize anything we know. but just above it, the corona, that wispy halo visible during eclipses, roars at temperatures over 1,000,000 degrees. It's like walking away from a campfire and suddenly feeling blistering heat instead of cool air. So what's cooking? The mystery, known as the coronal heating problem, has stumped astronomers for decades. One leading theory involves the sun's magnetic fields, tangled ropes of energy that snap and reconnect like cosmic rubber bands. These explosive events, called nanoflares, might inject enough heat into the corona to supercharge it. Another idea points to magnetic waves rippling outward from the sun's churning interior, transferring energy like an invisible furnace. But here's the catch: no single explanation fully accounts for that extreme temperature jump. Even stranger, the corona doesn't act like a typical hot gas. Instead of cooling as it expands, it stays scorching, defying the usual rules of physics. Spacecraft like NASA Parker Solar Probe are now diving closer than ever to the sun, braving the heat to unravel this puzzle. Every new data point brings us closer to understanding why the sun wears a crown of fire, one that burns brighter than the star itself. This isn't just academic curiosity. The corona's behavior drives solar winds that can disrupt satellites and power grids on Earth. Crack this mystery, and we might finally predict space weather with the same confidence as a terrestrial forecast. For now, the sun keeps its secrets blazing defiance in plain sight, daring us to look closer. Saturn's dazzling rings might look eternal, but they're practically newborns in cosmic terms. While the planet itself formed over 4 billion years ago, those iconic icy bands may have appeared as recently as 100 million years ago, back when dinosaurs still roamed Earth. How do we know the rings are too pristine? If they were ancient, constant bombardment by space dust should have darkened them over time. Instead, data from NASA Cassini mission revealed they're remarkably bright and clean, like freshly fallen snow. So where did they come from? One compelling theory points to a cataclysmic breakup, perhaps a wandering moon or comet ventured too close to Saturn's immense gravity. Tidal forces would have shredded the object, scattering its remains into orbit. Over millennia, those fragments collided and shattered further, grinding into the countless icy chunks we see today. Another clue: the rings are mostly water ice, just like many of Saturn's moons, hinting at a shared origin. But here's the real kicker: Saturn hasn't always had rings. For most of its existence, the planet circled the sun bare, a silent giant without its signature halo. That means if you could rewind the solar system's history, you'd find a version of Saturn completely unrecognizable to us. And the rings won't last forever. Scientists estimate they'll fade away in another 300 million years, pulled apart by gravity or eroded into Saturn's atmosphere. We're witnessing a fleeting masterpiece, a celestial spectacle that's here for just a cosmic blink. Mars hides a geological titan that dwarfs anything on Earth: Olympus Mons, a volcano so vast it defies imagination. Towering 16 miles high, this shield volcano makes Mount Everest look like a mere foothill. Picture a mountain stretching 2.5 times the height of Everest, with a base so wide it could cover the entire state of Arizona. But how did something this colossal form? The answer lies in Mars's quiet, forgiving geology. Unlike Earth, Mars lacks shifting tectonic plates. Instead, its crust sits stationary over hot spots, allowing lava to pile up in the same location for billions of years. With no plate movement to cut off its supply, Olympus Mons grew layer by layer, eruption after eruption, into the solar system's largest known volcano. And here's the kicker: Mars's weaker gravity played a crucial role. At just 38% of Earth's pull, the red planet's lower gravity let the volcano build upward without collapsing under its own weight, creating slopes so gentle you could hike them with barely a strain. But don't mistake its size for violence. Olympus Mons didn't erupt in catastrophic explosions. It oozed lava slowly, like syrup spreading across a pancake. That gradual buildup left behind a monument to patience, a mountain forged not in fury but in persistence. And while it's dormant now, some scientists speculate that it might not be entirely dead. Future eruptions, though unlikely anytime soon, could still reshape this already staggering landscape. Standing on its summit, you'd see no peak piercing the sky, just an endless plateau fading into the horizon. The view would stretch so far, the curvature of Mars itself might become visible. It's a reminder of how alien geology can be, and how much grander nature's constructions are when freed from Earth's limitations. Olympus Mons isn't just a mountain, it's a testament to time, gravity, and the raw power of a planet that played by entirely different rules. Pluto might be small, but its days are anything but quick. On this distant dwarf planet, a single rotation takes 6.5 Earth days, meaning from one sunrise to the next, you'd wait longer than an entire work week. That sluggish spin isn't the only quirk, because Pluto's axis tilts dramatically, like a top knocked off balance. Some regions experience decades of continuous sunlight followed by crushing darkness just as long. And then there's its orbit, a stretched-out ellipse that sends Pluto swinging from 30 to nearly 50 times Earth's distance from the Sun. When it's closest, its thin nitrogen atmosphere briefly thaws, creating hazy skies before freezing solid again as it retreats. The result, seasons so extreme they make Earth's winters look mild. One Plutonian year lasts 248 Earth years, so long that since its discovery in 1930, it still hasn't completed a full trip around the Sun. Here's the kicker: Pluto's spin and orbit are locked in a gravitational dance with its largest moon, Charon. The two orbit each other so closely that they always show the same face to one another, like partners in a never-ending waltz. Time moves differently out here, an eerie, slow-motion existence where the very concept of a day bends under the weight of deep space's quiet rules. Deep in the heart of the Milky Way, floating among the stars, there's a gas cloud with a surprising secret: it smells like raspberries. No, really, astronomers analyzing the molecular makeup of a massive dust cloud near our galaxy's center made an unexpected find: ethyl formate. That's the same chemical responsible for the sweet, slightly tart scent of raspberries and rum, oddly enough. So how does a giant cosmic cloud end up smelling like a fruit basket? When stars die, they spew out complex molecules that drift through space, eventually clumping together in these vast stellar nurseries. Most of these compounds are exotic and odorless, but ethyl formate is one of the rare exceptions our noses can recognize. It's a tiny detail in a grand cosmic recipe, proof that the universe cooks up flavors we can actually relate to. Of course, you wouldn't want to take a deep breath out there. That same cloud is packed with deadly chemicals like cyanide and methanols, so while the raspberry note might be tempting, it's definitely not a cosmic smoothie. Still, it's a wild reminder that the building blocks of familiar scents, even something as simple as fruit, are woven into the fabric of space itself. The universe isn't just vast and mysterious, it's oddly fragrant too. Tucked away in the constellation Boötes lies one of the universe's most baffling mysteries, a yawning chasm of nothingness so vast, it defies logic. Known as the Boötes Void, this spherical region stretches an astonishing 330 million light-years across, yet contains almost no galaxies. To put that in perspective, if you placed our Milky Way inside it, the nearest neighbor galaxy would be tens of millions of light-years away. It's like standing in the middle of an empty stadium the size of a continent, with only a handful of other people scattered at the very edges. So why is this void so eerily empty? One theory suggests it might be the aftermath of ancient cosmic collisions where smaller voids merged over billions of years, gobbling up galaxies in the process. Another idea points to dark energy, the mysterious force accelerating the universe's expansion, potentially stretching regions of space into barren wastelands. But here's the twist: the void isn't completely deserted. Astronomers have spotted about 60 lonely galaxies drifting inside, isolated islands in a sea of darkness. What makes these survivors even stranger? Some appear younger and bluer than expected, as if they're somehow forging new stars against impossible odds. Whether through sheer luck or some hidden cosmic mechanism, these galaxies cling to existence in a place where the universe seems to have given up. The Boötes Void isn't just an empty spot, it's a silent challenge to our understanding of how matter clusters together, a cosmic riddle written in the negative space of the night sky. Some stars don't just drift lazily through the galaxy, they're cosmic fugitives, racing at speeds so insane they can break free from the Milky Way altogether. These are hypervelocity stars, and their origin story starts with one of the universe's most destructive forces, a supermassive black hole. At the heart of our galaxy, Sagittarius lurks like a gravitational monster, and when a binary star system wanders too close, chaos unfolds. The black hole's immense gravity can rip the pair apart, flinging one star into oblivion, while slingshotting the other outward at over 1,000,000 miles per hour. That's fast enough to cross the entire United States in just 5 seconds, or to leave our galaxy behind entirely. Imagine being catapulted so hard you escape the Milky Way's grip forever, no return, no home, just endless void ahead. These rogue stars don't just vanish though. As they streak through intergalactic space, they leave trails of light, clues for astronomers to track their extraordinary journeys. Some might even carry planets along for the ride, if anything could survive the violent ejection in the first place. But here's the twist, not all hypervelocity stars come from black holes. A few might be survivors of dwarf galaxies torn apart by the Milky Way's gravity, or the result of supernova explosions kicking their sibling stars into overdrive. Each one tells a different story of cosmic violence, a testament to the forces that shape our universe, and while they're rare, only a handful have been confirmed so far. Their existence proves that even stars aren't always bound by the rules. Sometimes the universe flings them into the unknown like sparks from a celestial bonfire. Here's something that might catch you off guard. If you were floating in space without a spacesuit, you wouldn't hear a thing. Not the hum of distant stars, not the roar of a supernova, not even your own scream. Space is utterly, eerily silent, and the reason comes down to one simple rule: sound needs something to travel through. Unlike light, which zips effortlessly through the vacuum, sound waves require molecules to bump against each other, like a cosmic game of telephone. Out there, where atoms are scattered impossibly thin, there's just nothing to carry the vibrations. This isn't just theory, it's why astronauts on the moon had to rely on radios. When Neil Armstrong took his famous first steps, his words traveled to Earth as electrical signals, not sound waves. Without his headset, even the crackling of the lunar module's engine would have been completely muffled. Imagine standing next to a rocket launch in total silence, no thunderous roar, just the ground trembling beneath your feet. That's how disorienting space can be for our Earth-bound senses. But here's the twist: space isn't always silent for us. Probes like NASA Voyager have captured something called plasma waves, vibrations in the charged particles between stars. Converted into sound we can hear, these waves become haunting whistles and clicks, like ghosts whispering in the void. So while space itself may be soundless, the universe still finds ways to speak to us. We just have to listen in the right way. Right now our galaxy is hurtling toward disaster, but in the slowest, most spectacular way possible. The Milky Way and its neighboring giant, the Andromeda Galaxy, are locked in a gravitational tango, pulling each other closer at nearly 250,000 miles per hour. In about 4 billion years, these two cosmic titans will finally collide, a merger so vast it will reshape the night sky forever. But before you picture stars smashing together like some intergalactic demolition derby, here's the twist: space is mostly empty. Even in a collision of this scale, the actual stars are so far apart that they'll likely glide right past one another, like two flocks of birds passing in an enormous sky. The real drama will unfold in the invisible forces at play: gravity. As the galaxies intertwine, their dark matter halos will wrench and twist their shapes, flinging stars into chaotic new orbits. Over billions of years, spiral arms will stretch into streamers of light, and the two supermassive black holes at their cores will eventually spiral together in a final, violent embrace. For Earth's distant descendants, if any still exist, the view will be staggering. Andromeda, now just a faint smudge in our night sky, will grow larger and brighter as it approaches, eventually filling the heavens with swirling dust and newborn stars. By the time the merger completes, the Milky Way as we know it will be gone, replaced by a single elliptical galaxy some astronomers have nicknamed Milkdromeda. What's wild is that this isn't some rare cosmic fluke. Galactic collisions happen all the time. We're just lucky enough to live in an era where we can predict our own. So 4 billion years sounds like forever. It's a reminder that even the mightiest structures in the universe aren't permanent. Everything, even galaxies, has an expiration date. In the cosmic menagerie of extreme objects, few things push the limits of physics like neutron stars, stellar corpses that pack more mass than the sun into a city-sized ball. And the fastest among them spin at a rate that'll make your head spin too, up to 600 revolutions every single second. That's faster than a high-powered blender shredding through space-time itself. These aren't just any stars, they're pulsars, nature's precision lighthouses. When a massive star collapses in a supernova, its core crushes down until protons and electrons merge into neutrons, creating a material so dense a single sugar cube-sized chunk would weigh 1 billion tons on Earth. But the real magic happens with their rotation. As they spin, their powerful magnetic fields funnel energy into narrow beams that sweep across the cosmos like interstellar strobe lights. From Earth we detect these beams as rhythmic pulses, some so precise they rival atomic clocks in accuracy. Here's where it gets surreal. At those speeds, the surface of a neutron star moves at nearly a quarter the speed of light. The centrifugal forces are so intense that if these stars spun just a fraction faster, they'd tear themselves apart, and their gravity, it's strong enough to bend light into a visible halo around the star, warping the very fabric of space around them. Some even distort into oblate shapes, bulging at the equator like cosmic spinning tops. Yet pulsars aren't just curiosities, they're tools. Astronomers use their clockwork pulses to test Einstein's theory of relativity, map the Milky Way's magnetic fields, and even hunt for gravitational waves. They're the universe's way of showing us how matter behaves under conditions so extreme. They rewrite the rules we thought we knew. So the next time you see a twinkling star, remember, somewhere out there, a celestial powerhouse could be flashing at you like a frenetic cosmic metronome, each pulse a heartbeat from the edge of physics itself. Floating near the center of our galaxy, there's a cosmic cocktail so massive it could fuel every party on Earth for billions of years. Sagittarius B2, a vast molecular cloud, holds an astonishing secret. It's packed with billions of liters of ethyl alcohol. That's right, the same stuff in your favorite drink is drifting through space in quantities so huge, it boggles the mind. But before you imagine interstellar breweries, there's a catch. This cloud is mixed with toxic chemicals like cyanide, making it about as drinkable as rocket fuel. So how does alcohol form in the void of space? It all comes down to chemistry in the extreme. Within these frigid gas clouds, individual atoms collide and stick to dust grains, slowly building into complex molecules. Radiation from nearby stars provides the energy to rearrange these atoms, forging everything from simple carbon chains to surprisingly intricate organic compounds. Over eons, these reactions create a cosmic soup of alcohols, sugars, and other precursors to life, proof that the universe is a far more creative chemist than we'll ever be. What's truly remarkable is that Sagittarius B2 isn't alone. Similar clouds lurk throughout the galaxy, each a floating laboratory for molecule building. Some even contain sugars like glycolaldehyde, a key ingredient in RNA. These discoveries blur the line between space and biology, suggesting the raw ingredients for life might be scattered everywhere, waiting for the right conditions to mix. While we're not likely to find interstellar distilleries anytime soon, these boozy clouds remind us that space isn't just empty darkness, it's a vast, bustling factory of molecular wonders. Here's something that sounds straight out of science fiction: time doesn't tick the same way everywhere in the universe. Thanks to Einstein's theory of relativity, clocks actually run slower in stronger gravity fields. That means if you could stand near a black hole like an interstellar, hours might pass for you while decades fly by on Earth. But this isn't just a movie plot, it's real physics, and it even affects astronauts orbiting right above us. Take the International Space Station, for example. Floating about 250 miles up, it experiences weaker gravity than Earth's surface, and because of that, time there moves ever so slightly faster. Wait, what? That sounds backward, but here's the twist. While gravity slows time, the station's blistering orbital speed, 17,000 miles per hour, counteracts it. The net result, astronauts age about 0.05 seconds less per year than people on the ground. Not exactly immortality, but over 6 months in space, they'd return younger than if they'd stayed home, by roughly 0.07 seconds. Now that might seem too tiny to matter, but GPS satellites have to account for this effect daily. Without adjusting their clocks for both gravity and speed, your maps would be off by miles within minutes. It's a constant reminder that time isn't just a universal constant. It bends, stretches, and warps depending on where you are and how fast you're moving. The real jaw-dropper, near supermassive black holes where gravity is crushing, time could crawl to a near standstill. Imagine watching from a safe distance as a ship approaches the event horizon. Its crew would appear frozen, barely moving, while your own life rushed forward in fast forward. Einstein's equations predicted this over a century ago, and today's experiments with ultra-precise atomic clocks prove it's true. So next time you glance at your watch, remember, it's not just counting seconds. It's telling a story written by gravity, speed, and the strange fabric of space-time itself. Imagine a world with no sunrise, no sunset, just endless night stretching in all directions. Meet the rogue planets, cosmic orphans flung from their home solar systems to drift alone through the galaxy. These aren't your typical worlds. They've been violently ejected, sent careening into the void by gravitational chaos, untethered from any star's warmth or light. And they're far more common than you might think. Astronomers estimate there could be billions of these nomads wandering the Milky Way, outnumbering stars by a staggering ratio. Some might have formed directly from collapsing gas clouds, too small to ignite into stars but large enough to become planets untethered from birth. Others started life in ordinary solar systems before gravitational tugs, perhaps from a passing star or a collision with another planet, sent them flying into interstellar space like billiard balls knocked off the table. Here's the twist: many of these rogue worlds aren't frozen wastelands. Some may retain thick, heat-trapping atmospheres that keep their surfaces warm enough for liquid water, even without a sun. Tidal forces from their own moons or internal radioactive decay could provide enough energy to sustain underground oceans, hidden beneath layers of ice or rock. If life exists in these dark realms, it would thrive in perpetual twilight, untethered from the rhythms of day and night that govern life on Earth. The craziest part: we've barely begun detecting them. Without a star's light to reflect, rogue planets are nearly invisible. Only their faint infrared glow betrays their presence. Future telescopes might spot them by the way their gravity bends light from distant stars, revealing these lonely travelers in fleeting flashes. Every discovery challenges what we thought we knew about how planets form and survive. So next time you gaze at the night sky, remember, between the stars, countless invisible worlds could be drifting in the dark, unseen, untethered, but very much real. The galaxy isn't just a place of light and warmth, it's also home to wanderers lost in the abyss, carrying their secrets through the void. Floating 50 light-years away in the constellation Centaurus, there's a star that defies every jeweler's wildest dreams, BPM 37093, better known as Lucy. But this isn't just any stellar remnant, it's a cosmic diamond the size of Earth, forged in the unthinkable pressures of a dying sun's core. Lucy started life like many stars, burning bright for billions of years. But when it exhausted its nuclear fuel, it didn't go quietly. Shedding its outer layers, what remained was an ultra-dense white dwarf, a smoldering ember packing the mass of our sun into a sphere no bigger than Earth. At its heart, carbon atoms were squeezed so tightly by gravity that they crystallized into a colossal diamond lattice, cold and pristine after eons of stellar cooling. The Beatles' inspired nickname isn't just whimsy, It's a nod to the star's otherworldly nature. If you could somehow mine Lucy, its diamond core would weigh an incomprehensible 10 billion trillion carats. That's one followed by 34 zeros, enough to fill every jewelry store on Earth a billion times over. But here's the catch: this diamond isn't sparkling in some cosmic display case. It's locked inside a dying star, its crystalline heart vibrating like a struck tuning fork as seismic waves ripple through it, a phenomenon astronomers actually use to study its structure. What makes Lucy truly remarkable isn't just its absurd size, it's proof of what happens when a star's fiery chaos gives way to cold, ordered perfection. Most white dwarfs are thought to solidify over time, turning their cores into cosmic diamonds. Lucy just got there first, becoming a glittering tombstone for a star that traded nuclear fire for eternal crystalline silence. So while we'll never hold this celestial gem, it's a dazzling reminder: the universe doesn't just create stars and planets, it crafts masterpieces, and sometimes those masterpieces shine brighter than any jewel we could ever imagine. Lightning storms and hurricanes might dominate Earth's weather forecasts, but space has its own violent storms, and they don't need clouds or rain to wreak havoc. The Sun, our closest star, is the engine behind this cosmic chaos, blasting out eruptions so powerful they can shake entire planets. Solar flares explode with the energy of a billion atomic bombs, while coronal mass ejections, giant bubbles of magnetized gas, hurtle through space at millions of miles per hour. When these storms hit Earth, they don't just light up the sky with auroras, they can fry satellites, knock out power grids, and even scramble GPS signals. A solar flare isn't just a flash of light, it's a burst of radiation that races toward us in minutes, bombarding our atmosphere with X-rays. That surge can blind radio communications, leaving pilots and astronauts suddenly cut off. But the real danger comes hours or days later, when a coronal mass ejection arrives. Imagine a tsunami of charged particles slamming into Earth's magnetic field, stretching it like taffy until it snaps back, dumping energy into our upper atmosphere. The result: electrical current strong enough to overload transformers, like the one that left 6 million people in Quebec without power for 9 hours back in 1989. Here's the twist: space weather isn't just a modern problem. A solar superstorm in 1859, known as the Carrington event, sparked auroras so bright they woke people up at midnight, glowing as far south as Cuba. Telegraph systems, the internet of their day, failed catastrophically, with operators reporting sparks flying from their equipment. If a storm like that hit today, experts estimate it could cause trillions in damages, blacking out continents for months. Yet there's a silver lining. Space agencies and power companies now monitor the Sun like storm chasers tracking a hurricane, using satellites like NASA's Solar Dynamics Observatory to give us early warnings. And those dazzling auroras, they're just Earth's way of turning the Sun's tantrums into a light show, proof that even in the chaos of space, beauty and danger often go hand in hand. We think of the Moon as a silent, lifeless world, but beneath its dusty surface, it rumbles with quakes that would feel downright alien to anyone used to Earth's tremors. Unlike earthquakes, which last seconds or minutes, moonquakes can persist for hours, echoing through the lunar crust like a bell that just won't stop ringing. These otherworldly shakes come in different flavors. Some are triggered by meteor impacts, violent but brief. Others, though, are far stranger. As Earth's gravity tugs on the Moon, the stress fractures its brittle crust, creating deep tremors that resonate through its rigid interior. Without oceans or an atmosphere to dampen the vibrations, these quakes keep going long after their earthly cousins would have faded. Here's what's really eerie. Apollo astronauts left seismometers behind, and the data revealed moonquakes originating hundreds of miles below the surface, depths where Earth's quakes would be impossible. Scientists suspect the Moon's cooler, more brittle interior lets these waves travel uninterrupted, amplifying their duration. Imagine standing there as the ground beneath you shudders, not for seconds, but for an entire afternoon, a slow, eerie reminder that even dead worlds have hidden tectonic lives. The Moon might lack the geological hustle of Earth, but it's got its own haunting rhythm. a seismic whisper from a place where time moves differently. While most planets spin like tops as they orbit the Sun, Uranus rolls like a drunken cosmic bowling ball, tilted a staggering 98 degrees on its side. This ice giant's poles take turns pointing directly at the Sun, making its seasons more extreme than anywhere else in the solar system. Picture spending 21 Earth years in endless sunlight, followed by another 21 plunged into total darkness. That's not science fiction, it's just another day on Uranus. Scientists believe this bizarre orientation stems from a cataclysmic smash-up early in the planet's history. A collision with an object twice Earth's size could have knocked Uranus sideways, leaving it forever spinning with its equator perpendicular to its orbit. The impact might also explain why the planet's interior is oddly cold compared to other giants, like a cosmic punch drained its primordial heat. But the real oddity: Uranus's weather doesn't behave like anything we've seen. During its solstices, when one pole basks in constant sunlight, atmospheric storms erupt with surprising violence despite the weak solar energy. Then at equinox, when the Sun hangs over its equator, Uranus's magnetic field wobbles chaotically, as if disoriented by the sudden shift. Even its rings, discovered only in 1977, orbit vertically like bullseyes around a tilted target. This sideways world challenges everything we thought we knew about planetary formation. While Jupiter and Saturn proudly showcase their horizontal banded storms, Uranus whispers a different story, one of cosmic violence, forgotten heat, and seasons measured in decades rather than months. It's a reminder that in our solar system, normal is relative, and sometimes the strangest worlds hold the most revealing secrets. Here's a number that'll bend your brain: the observable universe holds more stars than all the grains of sand on every beach and desert across our entire planet. We're talking about a cosmic ocean where galaxies alone number in the hundreds of billions, each one a swirling city of stars. The Milky Way, just one of these galaxies, packs in over 100 billion stars. Now stack that against Earth's beaches, which hold roughly 7.5 quintillion grains of sand. That's a 7 followed by 18 zeros. Even that unimaginable figure gets dwarfed when you realize there are more galaxies in the cosmos than grains on our shores. But here's where scale gets truly dizzying. Some estimates suggest the total stellar count could exceed 1 septillion. That's a 1 with 24 zeros trailing behind it. Picture this: if every star were just a single grain of sand, you'd need a desert stretching light years to hold them all. And that's only the stars we can see, the observable universe. Beyond our cosmic horizon, there could be infinitely more, forever hidden by the expansion of space itself. What's wild is how this changes our place in the grand scheme. Our Sun, just one faint spark in a sea of fire. Our galaxy, a drop in an ocean stretching farther than light has traveled since the Big Bang. Yet every atom in our bodies was forged inside stars. So while we might feel small, we're also deeply connected to that vast stellar tapestry. Next time you're at the beach, scoop up a handful of sand. Each grain could represent a star, and you'd still need countless handfuls to even begin counting the cosmos. It's a humbling reminder: the universe doesn't just exceed our imagination, it crushes it under the weight of numbers we'll never fully grasp. Deep in the heart of the Perseus galaxy cluster, something extraordinary echoes through the cosmos, a black hole humming a note so deep, it defies human imagination. Astronomers studying the supermassive black hole at the cluster's core discovered pressure waves rippling through the surrounding gas waves that, when translated into sound, produce a tone 57 octaves below middle C. That's a frequency 1,000,000 billion times deeper than the lowest note a human ear can detect. Here's how it works: as this cosmic behemoth devours matter, it sends shock waves through the superheated plasma around it. These waves aren't sound as we know it. Space is still silent, but by scaling them up into the range of human hearing, scientists revealed a haunting, slow-motion melody. The original note takes one oscillation every 10 million years, a cosmic bassline stretching back to when our ancestors were just learning to walk upright. What's astonishing isn't just the sound itself, it's the energy behind it. The black hole's hum carries more power than all the stars in 1,000 Milky Ways combined. vibrating the fabric of an entire galaxy cluster like a tuning fork the size of the universe. And while we'll never hear it naturally, this discovery reshapes how we see black holes not just as destroyers, but as orchestrators of invisible symphonies. The Perseus black hole's song is more than a curiosity, it's a tool. By mapping these pressure waves, astronomers can trace how black holes shape their surroundings, redistributing energy across millions of light years. It's a reminder that even the most violent forces in nature can create patterns, rhythms, beauty in the chaos. So next time you hear a deep bass note, remember, out there, something infinitely older and more powerful is singing a tune we're only beginning to understand. The sun may look unchanging in our sky, but it's actually wasting away quite literally. Every second our star sheds an astonishing 4 million tons of mass, vanishing into pure energy through nuclear fusion. That's the weight of an entire skyscraper dissolving into light and heat every single moment. So how does this cosmic diet work? Deep in the sun's core, hydrogen atoms slam together under crushing pressure, fusing into helium. But here's the catch, a tiny fraction of their mass doesn't survive the process. Instead, it transforms into energy, following Einstein's famous equation E=mc². That energy slowly journeys outward, taking thousands of years to escape the sun's dense layers before finally reaching us as sunlight. Here's the wild part, despite this constant loss, the sun is so massive it's barely put a dent in its reserves. Over its 10 billion year lifespan, it will have burned through only about 1/10,000th of its total mass. Even losing 4 million tons per second, it has enough hydrogen fuel to keep shining for another 5 billion years long after humanity's distant descendants, if they exist, have evolved into something unrecognizable. But don't let that fool you into thinking the sun is eternal. Eventually, even this titanic furnace will exhaust its fuel, swelling into a red giant before collapsing into a cooling ember. For now though, every sunrise serves as a reminder we're basking in the glow of a star that's literally vanishing before our eyes, one atom at a time. Imagine a planet where the skies don't just rain water, they rain glass. Welcome to HD 118.733b, a world so extreme it makes even Venus look tame. This deep blue exoplanet, located 63 light-years away, whips around its star every 2.2 days, and its atmosphere is a literal hellscape. With wind screaming at over 5,000 miles per hour, 7 times the speed of sound, this place doesn't just have weather, it has nightmares, the culprit behind this horror show. Silicate particles floating in its scorching, 4,000-degree atmosphere. As these tiny grains get caught in supersonic wind currents, they don't just drift, they crystallize, forming razor-sharp glass shards midair. Picture a sandstorm, but instead of dust, the air is filled with molten droplets that instantly freeze into jagged projectiles, hurled sideways at bullet-like speeds. There's no gentle drizzle here, just a never-ending barrage of molten glass, slicing through the atmosphere in horizontal sheets. What's truly bizarre is how serene HD 118.733b looks from afar. Its deep azure hue, caused by scattered light from silicate clouds, gives it the deceptive appearance of a tranquil ocean world, but don't be fooled. That beautiful blue comes with a death sentence, an atmosphere so hostile, even a spaceship's hull would be sandblasted into oblivion in seconds. Yet for all its fury, this glass-strewn world teaches us something vital. Planets don't need to be habitable to be fascinating. 189,733b pushes atmospheric physics to its limits, showing just how bizarre weather can get when you stray beyond our solar system. It's a reminder that the universe isn't just stranger than we imagine, it's sharper too, in every sense of the word. Look up at the night sky, and you'll see one moon, but Earth actually has a secret companion hiding in plain sight. Meet Camelwa, a small asteroid that behaves like a second moon, tracing a bizarre dance around our planet without ever being truly bound by its gravity. This cosmic tag-along isn't orbiting Earth the way our familiar moon does. Instead, it circles the sun in near-perfect sync with us, taking just about a year to complete its loop, close enough that from Earth's perspective, it appears to pirouette around our planet in a delicate, corkscrew-like path. At its closest, Camel drifts about 9 million miles away, still far enough to remain invisible to the naked eye, yet close enough to earn the title of Earth's quasi-moon. What makes this space rock even more intriguing is where it might have come from. Spectral analysis suggests its surface bears a striking resemblance to lunar rocks, hinting that Camel could be a long-lost fragment of our moon, blasted into space by an ancient asteroid impact. Imagine a piece of the moon escaping Earth's gravity, only to wander the solar system for eons before fate pulled it back into our gravitational sphere. But don't expect it to stick around forever. Unlike our steadfast moon, Camel's orbit is unstable. Within a few centuries, subtle tugs from the sun and planets will likely nudge it away, sending it spiraling off on a new trajectory. For now, though, this celestial hitchhiker serves as a quiet reminder Earth's gravitational reach extends farther than we think, and even the loneliest space rocks can find temporary shelter in our cosmic neighborhood. Think space holds the record for extreme cold. Think again, the coldest natural place we've found isn't in some distant nebula, it's right here on Earth. In a laboratory, scientists chilled sodium atoms to a mind-bending 500 billionths of a degree above absolute zero. That's colder than the Boomerang Nebula, the previous record holder, where temperatures plunged to minus 458 degrees Fahrenheit. So how do we out-freeze the cosmos? The secret lies in quantum mechanics. Using lasers and magnetic fields, researchers slow atoms to a near standstill, stripping away almost all their thermal energy. At these temperatures, matter starts behaving in ways that defy intuition. Atoms merge into a single quantum wave, acting more like a ghostly superfluid than solid particles. It's a state so alien, even the vacuum of space can't compete. What's wild is that space itself isn't truly cold. The cosmic microwave background, the afterglow of the Big Bang, fills the universe with a faint warmth, clocking in at around minus 455 degrees Fahrenheit. That means pockets of our own planet are now colder than the void between galaxies. These ultra-cold experiments aren't just breaking records, they're unlocking secrets about dark energy, quantum gravity, and the fundamental laws of physics. The Boomerang Nebula still wins for naturally occurring chill, though. Its frigid temperatures come from gas expanding at breakneck speeds like cosmic refrigerant spraying outward. But here's the twist: Earth's artificial deep freeze might hold the key to understanding how the universe behaves at its most extreme. So while the nebula wears nature's crown, our labs are pushing boundaries the cosmos never dreamed of. Cold isn't just a measurement, it's a frontier, and sometimes the most groundbreaking discoveries happen right in our own backyards. Tucked away in Earth's orbit for over 3 decades, the Hubble Space Telescope has captured some of the most breathtaking images of our universe, but its true power lies in the mind-bending precision of its vision. This celestial observatory could spot a single firefly glowing on the surface of the moon, as if someone had left a tiny nightlight in the vast lunar darkness. Put another way, Hubble's resolution is sharp enough to distinguish 2 fireflies sitting just 10 feet apart from 250,000 miles away. To grasp just how staggering that is, imagine standing in New York City and trying to read the label on a soda can sitting all the way in Switzerland, not just spotting the can itself, but making out the fine print. That's the level of detail Hubble achieves when gazing across cosmic distances. Every fine spiral arm in a galaxy, every wisp of nebulous gas, every flicker of a distant star is brought into focus thanks to a mirror so precisely polished, its surface deviates by less than 1/1,000,000th of an inch from perfection. What makes Hubble's vision even more remarkable is how it cuts through the distortion of Earth's atmosphere. Ground-based telescopes, no matter how large, must peer through layers of turbulent air that blur fine details, like trying to read street signs through a rippling heat haze. But Hubble, floating above that atmospheric interference, delivers crystal-clear images that have rewritten astronomy textbooks. From measuring the expansion rate of the universe to spotting storm systems on Pluto, its razor-sharp gaze has turned distant cosmic mysteries into intimate portraits. Yet here's the twist: Hubble's vision isn't just about raw power, it's about patience. Some of its most iconic images required hours, sometimes days of exposure, slowly collecting photons from objects so faint, their light traveled billions of years before reaching its lens. Each snapshot is a time capsule, revealing universes as they existed long before Earth even formed. So while we marvel at Hubble's technical wizardry, let's not forget the deeper magic. It's a time machine, a detective, and an artist all in one. And somewhere out there, if a firefly ever dared to glow on the moon, this extraordinary telescope would be watching, proving once again that the universe's smallest details can be just as awe-inspiring as its grandest spectacles. And there you have it, 30 cosmic revelations that prove the universe is far stranger than any sci-fi movie. From diamond rain on Neptune to black holes humming deep space lullabies, we've journeyed through wonders that defy logic and stretch imagination. Each fact is a reminder, no matter how much we learn, space always keeps its best secrets just out of reach. But here's the real question: which fact rocked your universe the most? Was it Saturn's fleeting rings, forged when dinosaurs still ruled Earth, or perhaps the rogue planets drifting through eternal night, untethered from any star? Drop your favorite in the comments. We're dying to know what stunned you. If your brain's buzzing with cosmic curiosity, you're in the right place. Hit that subscribe button and ring the notification bell, because we're just getting started. The universe is packed with mysteries waiting to unravel, and we'll be here to explore them together. Until next time, keep looking up. The cosmos has plenty more surprises up its sleeve.